Welcome to this series on getting started with Python. Over the next few videos, we'll go from a blank setup to writing and running your own Python code. This first one is all about the tools, where you write the code, where it runs, and how to get around. We won't write anything from scratch just yet. We'll load up a program that already works, see what it does, and get comfortable in the environment first. Quick bit of context before we open anything. Anaconda is a free, widely used distribution of Python aimed at data science and scientific computing. Basically, a one stop install that sets up Python and the tools around it so you don't have to piece them together yourself. It's a bundle, so it comes with Python itself, a big set of commonly used packages already installed, and the tools we're going to use Spyder and Jupyter Notebook. Think of Anaconda as the umbrella, and everything we touch today lives underneath it. Let's open Anaconda Navigator first, just so you know what that is.
2 hours later.
So this is the Home tab. This is where you land on when Navigator opens. You'll see a set of tiles here, and each one is an application Anaconda can launch for you. The two we care about are Spyder and Jupyter Notebook. The others are alternative ways of working with Python. You might spot VS Code in here, for instance, which is another popular editor. Now, Navigator is the point and click way to launch things. It works, but it is a little slow to open. And there's a faster way that's worth getting used to early, the command line. So let's close Navigator and do the rest from there. This is Anaconda Prompt, the command line that comes with Anaconda. You open it straight from the start menu, just search for Anaconda Prompt, and this black window is where we'll type commands to launch our tools from here on out. Let's quickly confirm everything's installed and working. So we'll type out conda hyphen hyphen version and see what it prints out. It should print out the version of conda that's installed. And then we can do python hyphen hyphen version, which will also show you which version of Python is installed. So these two outputs confirm Anaconda and Python are both installed and responding. Now let's open Spyder. This is the app where we'll be writing and running Python code. Instead of going back to Navigator and clicking the tile, we'll just type out the name Spyder right here. Spyder is an IDE or an integrated development environment, which just means it bundles everything you need to write code, run it, and see the results all in one window instead of juggling separate tools. So this is the same Spyder that you'd get if you launched it from the Navigator. This is just a faster way in. So Spyder has a few different window arrangements built in. There's one called the MATLAB layout that a lot of people find comfortable. So let's switch to that first. So we'll go into window layouts, and then MATLAB layout. And you can see the windows that were distributed on the Spyder IDE is now arranged like MATLAB. But a quick note, this only changes where the panels sit. It's got nothing to do with colors or themes, it's just the arrangement of the windows. And it's not locked in either. You can grab any panel by its tab and drag it wherever you like. If you come up with an arrangement that you like, you can save it under the same tab, window layouts, and then save current view. So let's take a quick tour of the main panel just so you know what you're looking at. So first we'll look at the editor, which is the large panel on the center. This is where your code lives, where you write, open, and save it. The IPython console is right below it, and this is where the code actually runs and where you see any text output from your code. The variable explorer is on the top right. This shows every variable your program has created along with its value and type. It's a really handy way to peek at what your code is doing. The plots pane is usually tabbed next to the variable explorer. Any graphs or figures your code produces show up here. Then finally, the files pane on the left shows the folder you're currently working in and what's inside it. Before we open our program, let's point Spyder at the folder where our files live. Working out of a dedicated folder keeps your project tidy and importantly means the program can find its data files. So we'll go up to this top left, top right folder symbol, click on it, and then point it towards our documents and then Python. So I've got a folder here with two files in it, the Python program we're about to run, and a small text file of data it reads from. You can see both in the files pane. Now let's open the .py file, which is the program. Here it is in the editor. We're not going to pick it apart line by line today. That's what the next few videos are for. But let me give you a big picture of what this code does top to bottom. So the first couple of lines are for pulling in relevant libraries. One of them is math, which has values like pi and Euler's number and so on. And the other one is for drawing plots. Then the next couple of lines opens a text file called radii.txt that's in the same folder and reads a list of numbers out of it. These are the circle radii. For each radius, we then calculate the area of that circle and save it into a variable named values. It then print the radii and areas onto the console and finally draw a plot of the area against radius. So in plain terms, we're going to read some numbers from a file, do some math on each one of them, print the results, and graph them. So let's run the code and see what happens. Down here in the console, that's where our output is printed. The list of radii that it read in and the list of area it's calculated is displayed. And over here in the plots window, you can see the area on the vertical axis, the radius on the horizontal, and you can see the area climbing faster and faster as the radius grows, which is what you'd expect from a circle. Then if you go on to Variable Explorer, you can see the variables that the program created while it ran. So it has the list of radii, the list of areas, and then some other variables for opening the file and so on. So one more thing before we end this video, this is where Spyder really earns its keep. Let's make a small change and run it again. Right now, the program calculates area. Let's switch it to calculate circumference instead. So we'll only be changing one line. So we'll change pi r square in this line to 2 times pi times r. We'll also update the plot's y-axis label to make it from area to circumference as well as the title so that we can stay accurate to what we're plotting. We'll then save the file. We can use Control S to save the file. And if you see the name of the file, the asterisk indicates some unsaved changes. And then when you do Control S, it saves it and the asterisk goes away. And now we'll run it again. And so there it is. New numbers in the console and a new plot. Same program, one small edit, and then we can run it and see how the values change from area to circumference, and also the plot is now linear, which is the relationship between radius and circumference. So that's the whole video for today. A quick tour of the entire environment in which we're going to work in. We looked at Anaconda Navigator, opened the Anaconda Prompt, launched Spyder from the command line, set up the MATLAB layout, walked through the panels, and then loaded, ran, and edited a real program. In the next video, we'll do the same warm-up, but with Jupyter Notebook, a different way of working with Python that mixes code and written notes together. And in the videos after that, we'll actually start writing Python code ourselves. We'll be declaring variables using libraries like the ones that we use today, as well as things like NumPy and Pandas, and see how we can develop code around them.